let's talk about quadratic functions, or specifically graphing quadratic equations. So when we graph a quadratic equation, we get something called a parabola. And the parabola, as I just said, is the graph of a quadratic equation. Now, by quadratic equation, I mean an equation in this form: y equals ax squared plus bx plus c. And the important part there is the exponent 2 on that first x. So our degree here of our function, the highest exponent, is 2. It's an x squared function. And so we're going to go through these steps to graph one of these functions. First, we're going to find the axis of symmetry, and that is given by the equation x equals negative b over 2a. And by b and a, we're talking about the coefficients on x squared and x like this. Okay, now this is going to be the x value of our vertex, the vertex being the middle point of our parabola. Once we do that, we make a t-chart, use the axis of symmetry and the next two integers above and below for x. Then we put in those numbers, find the y values, and we can graph the points. Now here's the important part, and we'll talk more about this as we graph, but if we have not found the solutions by that point, these are the x-intercepts of the function, we're going to add more x values until we do. You'll see what we mean. Let's go ahead and practice. So we're going to do two examples here. First one, we have y equals x squared minus 2x minus 8. And remember, if you don't have a number coefficient, it's a 1. So it's actually a 1x squared here. So in this function, our a value is 1, our b value is negative 2, and the c value is negative 8. Okay, just good to keep in mind. Now, first of all, we want to find the axis of symmetry. That's going to be that middle line, that middle point for our parabola. And we do that by taking negative b over 2a. So negative b would be positive 2. 2a, that's 2 times 1, that's also just 2. So our axis of symmetry here is 1. And that is going to go here for x. Now, to find the rest of the points of our parabola, we're going to pick two integers above and below that value. So below would be 0 and negative 1. Above would be 2 and 3. So now we're just going to take these x values and put them into our function, which remember is x squared minus 2x minus 8, to get our y values. Okay, if you need space to do your work, you can always use the blank space off to the side here. So maybe we'll do that for this one anyway. X squared minus 2x minus 8. Okay, so we're just going to go right down the line. So first we'll do negative 1. So we'll have negative 1 squared, that's 1. 2 times negative 1 is negative 2, and we have minus negative 2, so plus 2 minus 8, that's negative 5. So our first value here is negative 5. Put in 0 for x, we get 0 minus 8. Well, that's negative 8. Put in 1 for x, we get 1 minus 2 minus 8. So that's negative 9, which is our vertex. That's our middle point there, 1, negative 9. All right, put in 2 for x, we get 2 times 2 is 4. 1 minus 4 minus 8. 0 minus 8 is negative 8. And let's put in 3 for x. We get 9 minus 6 minus 8. 9 minus 6 is 3, minus 8 is negative 5. Something you should notice here is if you do your math correctly, you see our y values are mirrors of each other. As long as you space them out the same, two integers above and below the vertex, they will be a mirror. And that is because of the shape of our graph here. So let's graph these points. Negative 1, negative 5, left 1, down 5. 0, negative 8. 1, negative 9. 2, negative 8. And 3, negative 5. Okay, so our graph is kind of this shape here, this U kind of V shape. Unfortunately, we have not found our x-intercepts yet. So let's do one more set of numbers. So that would be like 4 and negative 2. And I've just got to add them down here to the bottom. If I put 4 in for x, I get 16 minus 8 minus 8. And that's 0. I should get the same thing for negative 2. Negative 2, put in there, negative 2 squared is 4. Then 2 times 2 is 4, so plus 4 minus 8 is also 0. That's good, that's what I wanted. So that's negative 4, 0. Sorry, 4, 0. And negative 2, 0. So you can see now our graph continues through those points. And these are the solutions to our function here. This is where the x value is 0. So it's where the function, put 0 in the function here. It's where the y value is 0. So it's the x-intercepts of the function. These are also called roots or zeros, the solutions. Okay, and it's where the function is equal to 0. So there's our parabola, and you can see that our AOS, our axis of symmetry, was x equals 1. And that's the line we get through the vertex. The vertex is the point 1, negative 9. Our graph opens up. And the solutions here are 4 and negative 2. Those are the x values when the function is equal to 0. The x-intercepts. All right, let's try one more. Okay, for example B, we've got y equals negative x squared minus 5. So if you consider this one, there you don't see that x term in there, that b value. That means our b value is 0. So our a value here is negative 1, b is going to be 0, and c is negative 5. So to find our axis of symmetry, it's negative b over 2a. So negative b would be 0. 2a gives us negative 2, but 0 divided by negative 2 is just 0. So our vertex has an x value of 0. And if we're going to choose 2 points above, 2 points below, that would be negative 1, negative 2, and 1 and 2. So our function here is negative x squared minus 5, which is a little less work than the previous one, so I think I can fit it all right here. So I'm just going to plug these numbers in first, then we can get the answers because I want to use a different color, and that is less clicking for me. So if I put in negative 2 for x, that's negative 2 squared is 4, but we have that negative sign out front. So we end up with negative 4 minus 5. For negative 1 squared is positive 1, but that negative sign makes it negative 1 again. Negative 1 minus 5. 0 gives us 0 minus 5. Putting in 1 squared is 1, but again that negative sign makes it a negative 1 minus 5. And then for 2, I again get negative 4 minus 5. Right? That negative sign gets applied after we take that number squared. 2 times 2 is 4, negative 4 minus 5. So our answers here, we get negative 9, negative 6, negative 5, negative 6, and negative 9. And you can see again, we have a kind of a symmetrical list here. It's a mirror image of itself. So if you space out your x values correctly, your y values will also be symmetrical. So to graph these, negative 2, negative 9, right here, negative 1, negative 6, 0, negative 5, 1, negative 6, and 2, negative 9. Okay, notice our parabola opened downwards this time. That is because our a value is negative. You have that negative sign out front. It's going to kind of turn your parabola upside down. And so this graph will never cross the x-axis, which remember is where we found our solutions. So we're not going to have any solutions here because we don't have any numbers where the function is equal to 0. So our axis of symmetry was x equals 0, right down the middle. Okay, our vertex was the point 0, negative 5. Our graph opens down. And our solutions here, there are no solutions. Okay, so that is how to graph a quadratic function using a t-chart. Find the axis of symmetry, put in some numbers for x. If you space them out 2 integers above and 2 integers below the axis of symmetry, the x value of the vertex, you will get a nice symmetrical picture, which you can use then to find your solutions.